In this module we're going to look at external code. So far in our examples in building up our sample application, we've been creating action diagrams and writing our logic using action diagram statements. For example, we have our logon procedure step, which uses our validate password action block, and we've got some simple validation in there that a user ID and password are provided. And then you may remember from our very first exercise we just added this to-do note that we want to use, for example, LDAP to perform the validation. Whilst the majority of your application logic should be possible to code that within CAGen, there are certain functions where either you cannot directly call it in CAGen, or it may be more efficient to write native code. The idea with CAGen is you should use action diagram statements as much as possible to write your logic, but on occasions using external logic, and that means code that's written externally to the CAGen action diagram syntax, is either required or maybe a better solution. So in our validate password action block, we added a to-do note that we wanted to use LDAP to perform the validation. So I'm just going to change that now and remove this password not validated. And now I'm going to create what's called an external action block where I'm going to perform the validation of the password. So to start off with, I'm going to create a new action block, and I'm going to call it EAB validate password, and I'm going to give it a source member name of xvalpwd. So there's my validate password, and it starts off, I've just created a normal action block. To make it external, you detail the properties of the action block and you tick the external checkbox. And what that means then is that the code is written by hand rather than generated. There are some various properties that I'm going to untick. I don't need a statement number, and I don't need the missing flags, and also I'm not going to use high performance view parsing because I'm just going to have a single import and export view. So there's my external action block, now marked as external, and with an external action block you don't have any local views or entity action views, but you do typically have imports and exports. So I'm going to copy the import view and I'm going to copy the return code and message as my export views. And then, as with all action blocks, you view match. So now our validate password action block, apart from very simple validation, is going to call the external action block, passing in the user ID and password and receiving a result. Now, with the external action block, whilst you hand code the logic, you can generate the code to create a stub or starting point for your external action block source code, and we could generate it from here, or you can directly generate action blocks from the action diagram editor by pressing this generate code button. The only thing you need to check there with the preferences, if you check your generation preference, that tells you what language the code will be generated for. So in this case it's C, which is fine. So I'm going to generate that and it tell you what language it's generated it for. So it's generated it for Windows and C. And then in my model C directory is the external action block that's been generated. So if we take a look at that, what you get with an external action block is the import views, the export views, and then basically an empty function into which you write your user-written code. Because if you were to generate this action block again, it would overwrite the source code in this C directory. It's always a good idea to actually develop your external action block code in a separate directory, so you don't accidentally overwrite it by a freshly generated stub. So what I've got here is a standard location for external code would be an extrn folder, and I've actually got an external action block that I created earlier to do the validation work. So if we just take a look at that, it passes in the user ID and password, returns the code and message, and then don't really want to go through all of the code and what it does, but essentially the import views need to be trimmed because standard non-varying attributes CAGen pads with spaces. So I'm going to trim the user ID and trim the password, and then set up connections to LDAP, and then finally down here check the credentials, and then if the logon is successful, I set the export view code to 0. Otherwise, I'm going to return the LDAP error message into my CAGen message. So that's the code, and obviously for your own environment you would need to develop the external action block based on what security system you're using. So that's the C code. That needs to be compiled, and I've created a simple batch file which will compile the C code and then put it into a library, and you can name the library whatever you want, but CAGen by default looks for a library called extrnc.lib, so I'll just use that. So I'm going to put the object code into that externc.lib. So I can run the make, and that has now created my extrnc.lib. So having done that, I'm now ready to test that. So I'm going to regenerate my validate password and build my application. And normally that would succeed. In this case it's failed, and we can look at the build output and look at why that's failed. And the reason it's failed is that in my own external code I'm also calling some LDAP functions, and the LDAP library needs to also be available to the build, otherwise it can't resolve the LDAP functions, and that might be a common occurrence if you're building external code which needs additional libraries. So to specify those additional libraries, the way you would typically do that would be through the build tool profile, and an easy way of doing that would be to launch the build tool. It'll fail again when we run the build, but having launched the build tool, we can then take a look at the profile manager, and for the C code I need to add in any additional libraries, in this case my LDAP library, and then I can build that again. And that's built successfully because it's resolved the LDAP libraries. So what I can do now is test my application, and I can use the user ID. This will fail because John is not a valid user ID in our LDAP directory. So I get the message from LDAP, invalid credentials. Standard LDAP error message. If I use my own user ID, that will succeed, but I'm actually not defined in the user table on the system. But at least that's shown that the LDAP has successfully validated my password. So that's showing you the use of an external action block, where you have import views and export views. It's marked as external, and then you can code your external statements using whatever source code editor you like. Another way of writing external code is directly into the action diagram using a special statement called inline code. So for example, if when there's an error, I might want to prevent the user logging on for another 5 seconds to prevent them trying to press maybe enter multiple times. So give them a 5-second delay, and that there isn't a sleep function within the CAGen action diagram statements or functions, but there is a very simple C function to perform the sleep. So it would be possible to code that in an external action block, but really for a one-line statement there's no need. Instead, I can use this inline code and specify that the language I want is C. So this is inline code for C, and I'll sleep for 5,000 milliseconds. So now I can generate that I don't need to see the build tool every time, so for the next build I won't launch the build tool. And then test the application. So invalid credentials error message, and now I won't be able to do anything for 5 seconds whilst the sleep occurs, and then when 5 seconds are up, then I can press OK again. So that's just showing you there the use of this inline code. Inline code is fine for simple statements like that. You wouldn't want to write a complex piece of code in inline code because you don't have all of the source code editing features that you would have from your normal source code editor. But for simple statements, inline code is a perfectly acceptable alternative to external action blocks. The one thing to be wary of is that the inline code is targeted for a very specific language. So if I was to generate this procedure step for a web application with Java, then that code would not get executed. It would just get ignored if I was generating Java. So the danger here would be that you may have some code that you need to execute, and if you in the future were to change the language you're generating for, just that code would just get skipped. So it's something to be wary of, and you might want to prevent that happening by maybe creating some Java code and maybe a rubbish statement in there which would fail to compile. And then at least if you were to generate this for Java, you'd realize you had a problem and have to fill in the Java code for that statement. So that's one way you could achieve that. Whereas with an external action block, you would be forced to compile that for Java, otherwise the build would fail automatically. So that's showing you the use of external code, either as an external action block or as an inline code statement. And whilst I would not recommend you overuse external action block code where there is a perfectly acceptable way of coding the logic within CAGen action diagram statements, for either simple examples like this or where you can't code it in CAGen, for example the LDAP validation, then external action blocks are the way to do it.